Rapidly evolving world of artificial intelligence, a new player has emerged to shake things up. That is DeepSeek. This cutting-edge technology is revolutionizing the way we interact with AI, making it smarter, faster, and more efficient. But what exactly is DeepSeek? And why is it disrupting the AI sector? As we explore the world of DeepSeek, we'll discover how it's enabling us to code smarter with DeepSeek-Coder, how the latest versions DeepSeek-Coder V2 and the latest versions DeepSeek-VL are taking artificial intelligence to next heights. We'll also examine the capabilities of DeepSeek-VL2, DeepSeek-Prover v1.5 and DeepSeek-R1 and see how they are transforming the AI landscape. Additionally, we'll compare DeepSeek with other AI models like Qwen 2.51m and ChatGPT and explore the possibilities of running DeepSeek models in Google Colab. But with great power comes great responsibilities. So we will investigate whether DeepSeek is safe to use. So join us onto this journey as we delve into the world of DeepSeek, covering topics such as what DeepSeek is and its impact on AI sector, coding smarter with DeepSeek-Coder, the latest advancements in DeepSeek-VL and DeepSeek-VL2, the benefits of DeepSeek-Prover v1.5 and DeepSeek-R1, the comparison between the Qwen 2.5 and DeepSeek, and the ins and outs of running DeepSeek models in Google Colab, all while addressing the crucial question, is DeepSeek AI safe to use? So let's get started with understanding what is DeepSeek and why is it disrupting the AI sector. Basically, DeepSeek is a Chinese startup that has developed advanced artificial intelligence models including DeepSeek V3 and DeepSeek-R1 comparable to the industry-leading US models. Now, these DeepSeek AI models are disrupting the AI sector because they are 20 to 50 times cheaper to use than similar models from US companies like OpenAI. Also, they are comparable or better than industry-leading models in the US. They require less computing power and resources to train with a reported cost of less than $6 million. Now, how is DeepSeek achieving this? So, DeepSeek's success is attributed to its advanced AI algorithms developed by its team of experts. Also, its access to computing resources, possibly using NVIDIA H100 chips, although the company has not disclosed this information. A quantitative hedge fund that has invested in DeepSeek is also working on artificial general intelligence research. Now, what does this mean for the AI sector? So, this DeepSeek's disruption of this AI sector has raised doubts about the reasoning behind US tech companies' decision to invest billions of dollars in AI research. Also, it impacted the stock prices of companies like NVIDIA, which has seen its shares affected by DeepSeek's success. It has caught the attention of Beijing because DeepSeek's success has been noticed by the China's top political circles, with founder Liang attending a closed-door symposium hosted by the Chinese premium Qwen. Now, what's next for DeepSeek? Basically, this DeepSeek success has opened up new opportunities for the company, including expansion into new markets. That is, DeepSeek is looking to expand its reach into new markets, including the US and Europe. Also, DeepSeek is exploring partnership and collaborations with other companies and research institutions to further develop its AI technology. DeepSeek is committed to continued innovation and improvement of its AI model with a focus on developing more advanced and efficient algorithms. Now, this DeepSeek success has significant implications for the future of artificial intelligence, including increased competition. Because DeepSeek's entry into the artificial intelligence market has increased competition, which is driving innovation and improvement in artificial intelligence technology. DeepSeek's cheaper AI models make AI more accessible to the businessmen and the individuals, which could lead to more widespread adoption of AI technology. Also, DeepSeek's AI models have the potential to be applied in a wide range of industries, including healthcare, finance, and education. Now, despite its success, DeepSeek faces challenges ahead, including regulatory hurdles, because DeepSeek must navigate complex regulatory environments in different countries, which could impact its ability to expand into new markets. DeepSeek faces competition from established players in the AI market, including Google, Amazon, and Microsoft. Also, DeepSeek AI models must be secure and protected from cyber threats, which is a major challenge in the AI industry. So, in conclusion, DeepSeek's success has disrupted the AI sector and has significant implications for the future of artificial intelligence. Next comes DeepSeek-Coder, which is a type of artificial intelligence model designed to understand and generate code. It is like a super smart computer program that can help developers write code more efficiently. Now, DeepSeek-Coder is built using transformer architecture, which is a type of neural network. The DeepSeek-Coder model consists of the encoder, which takes in a sequence of tokens, say code, natural language, or a mix of both, and outputs a continuous representation of the input sequence. The decoder generates a sequence of tokens based on the output of encoder. Now, this code infilling module is responsible for filling the blanks in the given code snippet. It takes the output of the encoder and generates the completion for the incomplete code. Also, this program-aided math reasoning module is designed to solve math problems by generating programs. It takes the output of encoder and generates the program that solves the math problem. Now, how does DeepSeek-Coder works? So here the model is trained on the large data set of code. It learns to recognize patterns and relations between the code element. So when a user inputs a code prompt, the model uses its learned knowledge to generate the next token in the sequence. The model iterates through the code generation process using the previous output as input for the next token. And the final output is a complete code snippet. Now, its key features include context window. That is, DeepSeek-Coder has large context window which allows it to understand and generate code in a more nuanced way. Also, this model can fill in missing code elements, making it a powerful tool for code completion. DeepSeek-Coder supports multiple languages, making it a versatile tool for developers. Now, DeepSeek-Coder was trained on massive dataset of code files, including a mix of programming languages such as Python, Java, C++, and JavaScript. The training data consists of the large corpus of code which is used to fine-tune the model's weight and biases. This model is trained using the combination of masked language modeling and next sentence prediction. Now, several techniques are employed in DeepSeek-Coder model to achieve its impressive performance. First, this model is pre-trained on the massive corpus of code, which allows it to learn the patterns and structures of code. Also, this model is trained on the fill-in-the-blank objective, where it is given a code snippet with some missing tokens and is asked to fill them in. And this objective helps the model learn to generate coherent and context-dependent code. The model uses the context window extension technique to increase the context window size from 2048 to 16384 tokens. And this allows the model to capture longer range dependencies in the code. The model uses a custom tokenization scheme, which is a combination of word level and subword level tokenization. The model uses a positional encoding scheme to preserve the order of input tokens. Next, the model is trained on multiple tasks simultaneously, including code infilling, program-aided math reasoning, and natural language understanding. The model uses knowledge distillation to transfer knowledge from the larger models to smaller models, which helps to improve the performance of the smaller models. The model also uses ensemble methods to combine the prediction of multiple models, which helps to improve the overall performance. Now, this code infilling module is a key component of the DeepSeek-Coder module. It is designed to fill in the blanks in a code snippet, and here this module consists of code encoder, which takes in a code snippet and outputs a continuous representation of code. Infilling generator takes the output of code encoder and generates the completion of incomplete code. Infilling verifier takes the generated completion and verifies that it is correct and consistent with the surrounding code. Now, this code infilling module uses the combination of techniques like code parsing, which uses the code parser to parse the code snippet and extract the relevant information. Infilling synthesis uses infilling synthesis techniques to generate a completion of the incomplete code. Infilling verification uses infilling verification techniques to verify that the generated completion is correct and consistent with the surrounding code. Next comes the program-aided math reasoning module, which is another component of DeepSeek-Coder module. It is designed to solve math problems by generating programs. Here the module consists of math problem encoder, which takes in a math problem and outputs a continuous representation of the problem. Program generator takes the output of math problem encoder, generates a program that solves the math problem. And this program executor takes the generated program and executes it to obtain the solution of the math problem. This program-aided math reasoning module uses a combination of techniques like mathematical expression parsing, which uses a mathematical expression parser to parse the math problem and extract the relevant information. Program synthesis uses program synthesis technique to generate the program that solves the math problem. Program verification uses program verification technique to verify that the generated program is correct and solves the math problem. Now the results of DeepSeek-Coder training are impressive. First, this DeepSeek-Coder achieves state-of-art performance on several coding benchmarks. DeepSeek-Coder can complete code snippets with high accuracy. Also, DeepSeek-Coder can understand code semantics and syntax. And finally, this DeepSeek-Coder can help developers write code faster and more efficiently. Now, DeepSeek-Coder compares favorably to the existing model. Like it outperforms existing model on several coding benchmarks. It can complete code snippets with higher accuracy. It can understand code semantics and syntax better than existing model. Also, it can help developers write code faster and more efficiently than the existing model. Now, this DeepSeek-Coder can complete code more accurately and efficiently. Also, it can help developers write code faster and with fewer errors. And finally, this DeepSeek-Coder can suggest improvements to code quality and readability. Here we have discussed this paper whose reference we have given here. So in conclusion, we can say DeepSeek-Coder is a groundbreaking artificial power coding tool that has a potential to revolutionize the way we approach to software development. Next comes DeepSeek-Coder version 2. Which is a type of artificial intelligence model designed to understand and generate code like a super smart computer programmer. It is a language model, which means it is trained on vast amounts of text data, including code from various programming languages. Now, this DeepSeek-Coder V2 key features are code understanding. That is, it can comprehend code written in any programming language, be it Python, Java, C++, and more. It can generate code based on the given prompt specification or even a natural language description. The model can solve mathematical problems and reason about code, making it useful for tasks like debugging and optimization. And finally, it supports over 338 programming languages, making it a versatile tool for developers. Now, how does it work? So, this DeepSeek-Coder V2 uses a training called pre-training. And this is a technique where it is trained on massive data set of text including code to learn patterns and relations. This pre-training enables the model to develop a deep understanding of programming concepts, syntax, and semantics. So when you input a prompt or specification, the model uses this pre-trained knowledge to generate code that meets the requirement. It is like having a highly skilled programmer at your fingertips. Now there are certain research gaps in previous literatures. Like most models struggle to understand the context of code, leading to poor performance in complex programming languages. Existing models lack strong mathematical reasoning capabilities, making solving mathematical problems and reasoning about code difficult. Also, they are designed for the specific programming languages, limiting their ability or applicability to other languages. And finally, they generate code which lacks quality, readability, and maintainability. Now, because of these gaps, DeepSeek-Coder addresses the research gaps and created the novelty, like it uses the novel attention mechanism to better understand the code's context. The model incorporates advanced mathematical reasoning capabilities, enabling it to solve complex mathematical problems. DeepSeek-Coder V2 supports over 338 programming languages, making it a versatile tool for developers. And finally, it is designed to produce readable, maintainable, and efficient code. Now, this dataset used to train DeepSeek-Coder V2 consists of large-scale code repositories. That is, the model is trained on massive dataset of code from popular repositories like GitHub, GitLab, and Bitbucket. This dataset includes codes from various programming languages, ensuring the model's language-agnostic capabilities. Also, the dataset is filtered to include only high-quality, readable, and maintainable code. Now, its training policy involves pre-training, that is, model is pre-trained on large dataset to learn general programming concepts and patterns. This pre-trained model is fine-tuned on specific tasks such as code completion, bug fixing, and code review. And finally, this model is trained on multiple tasks simultaneously, enabling it to develop a deeper understanding of programming concepts. Here, this model architecture consists of encoder-decoder structure, where the encoder processes the input code and decoder generates the output code. The model incorporates an attention mechanism to focus on specific parts of input code when generating the output code. Also, this method or the model uses a mathematical reasoning module to solve mathematical problems and reason about code. Now, this training hyperparameters include the batch size, which is set to 32, allowing the model to process multiple code samples simultaneously. The learning rate is set, enabling the model to learn from the data set effectively. Also, the model is trained for 100 epochs, ensuring it converges to an optimal solution. Now, the model is evaluated on various tasks including code completion, where it achieves an accuracy of 90%. Also, the model successfully fixes 80% of bugs in the test dataset, and it identifies 85% of code quality issues in the test dataset. While DeepSeek-Coder V2 shows promising results, it has some limitations. Like, this model may struggle with domain-specific codes requiring additional training data. The model may overfit to the training data, requiring techniques like regularization to prevent overfitting. Next comes its future work, which includes incorporating domain-specific knowledge into the model to improve the performance on domain-specific code. Developing techniques to explain the model's decision and outputs, increasing transparency and trust in the model. Also, it includes applying DeepSeek-Coder V2 to new tasks such as code summarization, code search, and code recommendation. And finally, it includes exploring the use of multimodal techniques to incorporate additional data sources and developing interfaces and techniques to enable effective human-AI collaborations. And finally, also we can add explainability and transparency, where we can add investigating techniques to provide more detailed explanation of the model's decision and outputs, enabling developers to understand and trust the generated code. Now, DeepSeek-Coder V2 has numerous potential applications, which includes assisting developers with code completion, reducing development time, and increasing productivity. Also, it helps in developers in identifying and fixing bugs, improving the code quality and reliability. It provides automated code reviews, identifying areas for improvement and suggesting optimization. Also, it generates high-quality code for specific tasks or application, reducing development time and effort. And finally, it can summarize large code bases, providing developers with a concise overview of the code structure and functionality. Now, DeepSeek-Coder has the potential to significantly impact the software industry, enabling developers to improve code quality by generating high-quality code that is readable, maintainable, and efficient. Also, it reduces development time and enhances the collaboration. Finally, it reduces the cost associated with the software development, maintenance, and debugging by generating high-quality codes. So here we are giving the reference of the paper which we have just discussed. So in conclusion, this DeepSeek-Coder V2 is a groundbreaking AI model that has the potential to revolutionize the software development industry. Next comes DeepSeek-VL, which is a new artificial intelligence model that combines computer vision and natural language processing to understand and generate text based on images. Here, the model is designed to bridge the gap between the vision and language, enabling more accurate and informative text generations. Now, previous models have struggled to effectively integrate vision and language, resulting in limited performances. And these are the main research gaps in the literature which led to the novelty of the DeepSeek-VL. First, most existing datasets are small and limited in scope, making it difficult to train models that can generalize well. Also, current models often rely on simple concatenation or attention mechanism, which are not sufficient to capture complex relations between the vision and language. And finally, models are often not fine-tuned for specific tasks, leading to suboptimal performance. Now, DeepSeek-VL addresses these gaps by creating a large dataset of images and corresponding text. Also, a new architecture is proposed which combines vision and language modules to effectively capture their relations. And finally, this model is fine-tuned for various tasks such as text generation, question answering, and image captioning. Now, this data set used in this one consists of two parts. First, a large data set of images and text is created, which includes various genres such as the news articles, books, and websites. Also, a small data set is constructed for fine-tuning the model on specific tasks such as text generation and question answering. Now, this DeepSeek-VL is a multi-modal model that can understand and generate text, images, and other forms of data. And it consists of three main modules. First, hybrid vision encoder is responsible for extracting visual features from images. Then vision language adapter connects the visual features to the language model. And finally, language module generates text based on the input data. Now this hybrid vision encoder is a combination of two vision encoders. First, SAM-B, which is a high resolution vision encoder that processes images at the resolution of 1024 into 1024 and extracts detailed features from the images. SIG-LIP-L is a low resolution vision encoder that processes images at resolution of 384 into 384 and extracts semantic features from the images. So this hybrid vision encoder combines the features from both SAM-B and SIG-LIP-L to create a rich representation of image. Now vision language adapter is a two-layer hybrid multi-layer perceptron that connects the visual features to the language model. It processes the visual features from the hybrid vision encoder and converts them into the format that can be understood by language model. Now, language model is a deep neural network that generates text based on the input data. It is built on the top of DeepSeek large language model and uses pre-norm structure with RMS norm function and Swiglu activation function. And here its main components are rotary embeddings, which is a technique used to encode positional information in the input data. Tokenizer is a component that breaks down the input text into smaller tokens that can be processed by the model. GALU activation is a type of activation function used in the model to introduce non-linearity. DeepSeek model comes in two sizes. First, the DeepSeek-VL1B, which is built on the top of the DeepSeek LLM-1B and has been trained on approximate corpus of 500 billion text tokens. DeepSeek-VL7B is built on the top of DeepSeek LLM-7B model and has been trained on estimated 2 trillion text tokens. Now its training pipeline consists of 3 stages, where the stage 1, the vision language adapter is trained while keeping the hybrid vision encoder language model fixed. So here the goal is to teach the model to understand the relation between the images and text, and it uses a dataset of 1.25 million image text pair and 2.5 million document OCR rendering pairs. It freezes the vision encoder and language model and only train the vision language adapter, and the model learns to connect visual and linguistic elements in the embedding stage. In the stage 2, both vision language adapter and language model are trainable, and the model is trained using the combination of visual and language data. Here the goal is to enable the model to comprehend multi-model inputs, be it images and text. And here it unfrees the language model and vision language adapter and train them together. Here the model may forget its language capabilities when trained on multi-model data, and it uses a joint language multi-model training strategy where the model is trained on both language and multimodal data. So it results in the model which balances its language and multimodal capabilities. Now in the stage 3, the model is fine-tuned on specific tasks such as the visual question answering or image captioning using the combination of visual and language data. And here its goal is to improve the model's ability to follow instructions and engage in dialogue. So it fine-tuned the pre-trained models using instruction-based fine-tuning and dialogue data and optimize the language model, vision language adapter and hybrid vision encoder, and makes the model more proficient in following instructions and engaging in dialogues. Now here its key concepts includes vision language adapter, joint language multi-models and other things. Now hyperparameters used to train DeepSeek-VL are model size, which is the number of parameters in the model. Batch size is the number of samples used to compute the gradient of the loss function. Learning rate is the step size used to update the model's parameters. Then optimize and training time. So it is using 1.5 billion parameters with the batch size of 2048. Optimizer is Adam and the training time is 100 epochs. Next, DeepSeek-VL was trained on the large-scale infrastructure consisting of GPU clusters, TPU clusters, distributed training, so where the model was trained using distributed training frameworks such as Horovod or DeepSeek to scale the training process. Also, this training data was stored on large-scale storage systems such as HDFS or Ceph. And the infrastructure used to train DeepSeek-VL includes 128 NVIDIA V100 GPUs, 16 Google TPUs, 100 GB of memory per GPU and 1 PB of storage. Now, this model is evaluated on various benchmarks, including public multi-model benchmark, such as visual question answering and image captioning. Also, this model is evaluated on public language benchmarks, such as text generation, question answering, and evaluated by human evaluators to assess its performance on various tasks. DeepSeek-VL is compared with other state-of-art models on various benchmarks, and the result shows that it outperforms other models on visual question answering. Also, it achieves state-of-art performance on image captioning benchmarks. It outperforms other models on text generation benchmarks. Now, its real-world applications include image search, visual question answering, image captioning, and finally, it's used for text generation, where users can generate text based on images or other context. Its future work includes improving efficiency, expanding applications, exploring new architectures and techniques to further improve the performance of DeepSeek-VL, and exploring multi-model learning techniques to enable DeepSeek-VL to learn from multiple sources of data such as images, text, and audio. While DeepSeek-VL is a powerful model, it's not perfect, and some limitations include the model requires significant computational resource and memory. Also, the quality of dataset may affect the model's performance, and this is the paper which we have discussed in this. So in conclusion, DeepSeek-VL is a groundbreaking AI model that has the potential to revolutionize the way we interact with technology and access information. Now comes the DeepSeek-VL2, which is a type of artificial intelligence model that combines computer vision and natural language processing to understand and generate text and images. It is a multi-modal large language model that can perform various tasks such as text-to-image synthesis, image-to-text synthesis, visual question answering, image captioning, and text-image retrieval. Now, previous multi-models had several limitations, like they were trained on synthetic or limited dataset which did not reflect real-world scenario. Also, the models focused more on text processing and neglected the importance of visual information. And these models were evaluated using simple metrics that didn't capture the complexity of multi-modal tasks. DeepSeek-VL2 addresses these limitations by using a large-scale dataset where the model is trained on massive dataset of text-image pairs which reflects real-world scenarios. Also, the model uses multi-modal architecture that combines visual and textual information to improve understanding and generation. And finally, the model is evaluated using more comprehensive metrics that capture the complexity of multi-modal tasks. Here, the dataset used to train DeepSeek-VL2 consists of text-image pairs, diverse data sources, and human-annotated dataset. Its training policy includes masked language modeling, where it is trained to predict masked tokens in a text. Also, the model is trained to predict whether the given text or images are matched. And finally, the model is trained to generate images from text description. Here, this model architecture consists of text encoder, which is a transformer-based encoder that processes input data, convolutional neural network that processes the image input, a fusion module that combines the text and image features, and the decoder that is a transformer-based decoder that generates the output text or images. Now, the model is trained using the hyperparameters like 256 batch size, 512 sequence length, 224 into 224 image size, 10 number of epochs, learning rate. Now, the model is evaluated using various matrices like Blue score, which measures the quality of generated text, Rough score, which measures the quality of generated text, then image generation, and image text matching accuracy. Its key features includes picture of experts architecture. That is, it allows it to specialize in different tasks and multimodalities. This architecture enables the model to efficiently process and generate high-quality text and images. DeepSeek-VL2 uses progressive scaling strategy, which involves gradually increasing the model's capability and complexity during training, and this approach enables the model to learn more effective representation of text and images. DeepSeek-VL2 is fine-tuned using instruction tuning, which involves adjusting the model's parameter to better align with specific task and objective, and this approach enables the model to perform well on a wide range of tasks. And finally, DeepSeek-VL2 is pre-trained on large-scale dataset of text and images, which enables it to learn generalizable representation of language and vision. Its technical details includes approximately 10 billion parameters, making it a relatively large model. DeepSeek-VL is trained on a dataset of over 100 million text-image pairs. Also, it is trained using the combination of objectives including masked language modeling, image reconstruction, and adversarial training. And DeepSeek-VL2 uses a combination of beam search and sampling to generate text and images. Its advantages includes improved performance on the benchmarks like text-to-image synthesis, image-to-text synthesis, and visual question answering. DeepSeek-VL2 can be fine-tuned for the specific task and applications, making it a versatile model for the wide range of use cases. Also, DeepSeek-VL2 has the potential applications in areas such as the content creation, visual assistant, and healthcare. While DeepSeek-VL2 achieves state-of-art results, it has some limitations where model requires significant computational resources to train and evaluate. The quality of dataset can affect the performance of model. Also, the evaluation metrics used may not capture all aspects of multimodal task. Its future work includes improving the model's architecture, where it can explore new architectures that can better integrate vision and language. Also collecting more data to further improve the model's performance and creating more comprehensive metrics that capture the complexity of multimodal tasks. And finally, using DeepSeek-VL2 in real-world applications such as image captioning, visual question answering, and text-to-image synthesis. Here is a reference of the paper that we have discussed. So in conclusion, DeepSeek-VL2 represents a significant advancement in the field of multimodal learning, offering a powerful and flexible framework for integrating natural language processing and computer vision. Next comes DeepSeek Prover v1.5, which is a machine learning model designed to automate theorem proving in mathematics. Here the goal is to create a system that can prove mathematical theorems without human intervention. The model builds upon previous research in the field addressing the gaps and limitations in existing models. So these previous models had limitations such as lack of scalability. Also, the models were not able to learn from the wider range of mathematical domains. The models were not able to explore the vast search space of possible proofs. Also, existing evaluation metrics were not comprehensive enough to measure the model's performance. DeepSeek Prover v1.5 addresses these gaps by introducing scalable architecture. And the model can learn from a wide range of mathematical domains. The model uses advanced techniques to explore the search space of possible proofs. And finally, new evaluation matrices are introduced to measure the model's performance more accurately. The model is trained on a large dataset of mathematical problems, including theorem statements, which is a collection of theorem statements from various mathematical domains. Also, a set of proofs for each theorem statement and a collection of intermediate steps and lemmas used in the proofs. DeepSeek Prover v1.5 consists of three primary components, where a pre-trained transformer-based language model, which generates potential proof steps based on the input problem statement, proof search engine, which is a custom-built Monte Carlo tree search algorithm that explores the proof search space guided by the LLM suggestions, and a formal proof checker such as Lean4 that verifies the correctness of generated proof. Now, its training policy includes supervised learning, where the model is trained on labeled data, including theorem statements and proofs. Reinforcement learning is where the model is trained to optimize the reward function that encourages it to find correct proofs. And finally, the model is trained to generate intermediate steps and lemmas. Here, the model consists of the encoder, which is a neural network that encodes the theorem statements and intermediate steps into the vector representation. Decoder is a neural network that generates the proof from the encoded vector representation, and the search module that explores the search space of possible proofs using advanced strategies like beam search, Monte Carlo tree search. Now, MCTS or the Monte Carlo tree search is a search algorithm used to find the best sequence of actions or the tactics to prove a mathematical theorem. It combines the strength of tree search and Monte Carlo methods to efficiently explore the vast search space. Its key components include the tree search, where the tree data structure represents the search space where each node corresponds to proof state and edges represent transition between states. Monte Carlo methods are where the random sampling is used to estimate the value of each node, guiding the search towards promising areas. Truncate and resume mechanism is a novel approach that truncates the generated proof at the first error, parses the successful segments into individual tactics, and resumes the search for that point. Now, MCTS algorithm consists of four main steps, where it chooses a node to expand based on the tree policy, which balances exploration and exploitation, and generate a new proof by expanding the selected node using the language model to predict the next tactics, verify the generated proof using theorem prover. If the proof is correct, the search terminates. And finally, update the node values and tree policy based on the outcome of the simulation. Now, its equations includes tree policy, where the tree policy selects the node with the highest estimated values. UCP value estimates the expected reward of taking action A in state S. Intrinsic reward encourages exploration by awarding a maximal amount of reward upon reaching an unseen state. And discounted upper confidence bounds are used to handle non-stationary rewards. And finally, this to improve the efficiency, it is parallelized using route parallelization, where multiple MCTS runners are deployed, each with a language model and batch size of 512 for proof generation. Each search tree is managed by 32 thread workers parallelizing to tree iteration steps, and a virtual reward is assigned to ongoing iterations to encourage diverse node selections among concurrent thread workers. Reinforcement learning is used to improve the mathematical reasoning capabilities of fine-tuned language models, so DeepSeek Prover v1.5 SFT by incorporating feedback from Proof Assistant. And this process results in a new model. Its key components include the prompt, which is a subset of theorem statement from supervised fine-tuning data. Then a reward, which is the Proof Assistant provides a binary reward signal. 1 if the generated proof is correct and 0 otherwise. So to mitigate the sparsity of this reward signal, the training prompts are chosen to be challenging yet achievable for the supervised fine-tuning model. Also, reinforcement learning algorithm, that is a group relative policy optimization, is used, which optimizes the model based on the relative rewards of outputs within a group of candidate proofs. Now this group relative policy optimization, here a group of 32 candidate proofs is sampled for each theorem prompt. Then the rewards are calculated based on the relative performance of the candidate proofs within the group, and the model is optimized to maximize the relative rewards. Its training settings includes initial model, where the supervised fine-tuned model serves as the initial model and reference model for imposing Kullback liberal divergence penalty. A constant learning rate of 5e-6 is used, and the KL penalty coefficient is set to 0.02. The batch size is configured to 512 and the maximum length of the candidate proof is set to 2048. Now these are some important facts, where the binary reward signal is sparse, especially for challenging problems. Also, the training prompts are chosen to be challenging yet achievable for the supervised fine-tuning model. Group relative nature, that is well suited for this task because of its group relative nature, which aligns with the prompt selection strategy. And the KL penalty is used to prevent the model from deviating too far from the initial models. So by incorporating reinforcement learning from proof assistant feedback, the DeepSeek Prover v1.5 RL is able to improve the mathematical reasoning capabilities. The model is evaluated in the test data set of mathematical problems, and the result shows improved performance, increased efficiency, and better exploration. DeepSeek Prover v1.5 combines the strength of large language models and traditional ATP systems, where the large language models generate potential proof systems, which are then evaluated and refined by proof search engines. Also, the proof search engine uses a Monte Carlo tree search algorithm to explore the proof search space efficiently. This approach allows the system to focus on most promising proof paths. To mitigate the limitations of large language models, DeepSeek Prover v1.5 employs a truncate and resume mechanism, which involves truncating the proof search at a certain depth and resuming it with a new set of LLM-generated suggestions. And the system then can complete partial proofs by generating the remaining proof steps. DeepSeek Prover provides an interactive model allowing users to input problems, and it comes with a comprehensive library of mathematical theories and concepts. Its technical details includes LLM training, where it is trained on large dataset of mathematical texts including proofs, theorems, and definitions. The proof search engine is optimized using the combination of techniques including alpha-beta pruning, iterative deepening, and transposition tables. DeepSeek Prover v1.5 integrates with a formal proof checkers like Lean4, which verifies the correctness of the generated proofs. And finally, the system allows for parameter tuning, enabling users to adjust the LLM's suggestion threshold, proof search depth, and other parameters to optimize performance. Its advantages include improved proof search and the enhanced proof completion. Also, the interactive mode and extensive library supports makes it easier for the users to work with the system. While DeepSeek Prover v1.5 shows promising results, there are still limitations like limited domain knowledge. Also, the model may struggle with very large search spaces. Its applications includes formal verification, mathematical discovery, and education. And this is the reference of the paper which we discussed in this. So in conclusion, DeepSeek Prover v1.5 represents a significant breakthrough in the field of automated theorem proving, offering a powerful and efficient solution for generating and verifying mathematical proofs. Next comes DeepSeek R1, which is a type of artificial intelligence model that is designed to improve the reasoning and problem-solving abilities of large language models. It is like a super smart computer program that can understand and answer complex questions, solve math problems, and even write code. The techniques involved in DeepSeek R1 includes reinforcement learning, which is a type of machine learning where the agent learns to take actions in an environment to maximize the reward signal. And the agent learns through trial and error, receiving rewards or penalties for its action. So imagine you are training a child to tidy up their room. You give them a reward, that is a sticker for each toy they put away, and a penalty, say a timeout for each toy they leave out. The child learns to put away the toys to maximize the reward. DeepSeek R1 reinforcement learning used to train the model to generate answers to the question, where the model receives a reward for generating correct answers and a penalty for generating incorrect ones. And this process helps the model learn to generate accurate answers. Next, the chain of thought reasoning, which is a technique that encourages the model to generate intermediate steps to solve complex problems, and it is done by providing the model with a prompt that asks for the step-by-step solution. Now, DeepSeek applications. So in the DeepSeek R1, chain of thought reasoning is used to generate step-by-step solutions to complex problems, where the model is trained to provide intermediate steps, making it easier to understand and evaluate its reasoning. Then supervised fine-tuning is a technique where the pre-trained model is fine-tuned on specific tasks with labeled data, which involves adjusting the model's parameters to fit the new task. So suppose you have a pre-trained model that can recognize objects and images, and you want to fine-tune it to recognize specific types of cars. You collect the data set of images of cars with labels like sedan, truck, etc., and uses the supervised fine-tuning to adjust the model's parameters to recognize these specific types of car. In DeepSeek R1, supervised fine-tuning is used to fine-tune the model on specific tasks such as question answering or text generation. Now, distillation is a technique where the larger model, say the teacher, is used to train a smaller model, say the student. Now, the student model learns to mimic the teacher's model behavior, effectively transferring knowledge from the larger model to the smaller one. So, suppose you have a large complex model that can recognize objects and images, and you want to create a smaller, more efficient model that can perform the same task. You can use distillation to train the smaller model, which learns to mimic the behavior of larger model. In DeepSeek R1, distillation is used to transfer knowledge from the larger model to the smaller one, and this allows a smaller model to perform tasks that would normally require a larger model, making it more efficient and scalable. Next comes Monte Carlo tree search, which is a search algorithm that uses random sampling to explore possible solutions. It is commonly used in games like Go and chess to find the best moves. So suppose you are playing a game of chess and you want to decide which move to make. You can use this Monte Carlo search algorithm to explore the possible moves, simulating games and evaluating the outcomes. And the algorithm helps you choose the best move by considering multiple possibilities. In DeepSeek R1, this Monte Carlo tree search algorithm is used to explore possible solutions to complex problems, and this algorithm helps a model generate answers by considering multiple possibilities. Now, previous gaps of the literatures. This is the chain of thoughts, distillations, Monte Carlo. Now, previous works of literature had several gaps like lack of reasoning capabilities, insufficient training data, inability to handle ambiguity, and limited scalability. Now, how DeepSeek R1 overcomes these gaps? So, it overcomes these gaps by using chain of thought reasoning. Then large-scale pre-training, where it is pre-trained on massive dataset which covers a wide range of topics and questions, making it more knowledgeable and effective. It uses the techniques like Monte Carlo tree search to handle ambiguous or unclear questions. And it uses the distillation to transfer knowledge from larger model to smaller one, making it more efficient and scalable. Some of the key mathematical equations include reinforcement learning objective, chain of thought reasoning, Monte Carlo tree search. Here its major contributions includes integrating multiple techniques where integrate reinforcement learning, chain of thought reasoning, supervised fine-tuning, distillation, and Monte Carlo tree search to create a powerful model that can reason and generate high-quality text. Also, DeepSeek R1 is pre-trained on massive dataset which allows it to learn a wide range of knowledge and skills. And finally, DeepSeek R1 uses techniques like Monte Carlo tree search to handle ambiguous or unclear questions. Its working includes training, where it is trained on large data set of questions and answers using combination of reinforcement learning, chain of thought reasoning, supervised fine-tuning, distillation, and Monte Carlo tree search During inference, DeepSeek-R1 uses the trained models to generate answers to new questions by exploring possible solutions and evaluating the outcomes. DeepSeek-R1 uses knowledge graphs to store and retrieve information, which helps it to generate more accurate and informative answers. Other important information includes scalability, where it is designed to be scalable and can be used to answer the wide range of questions from simple to complex. It can be fine-tuned for specific tasks such as question answering or text generation. Also, it provides explanation for its answers, which can help you build trust and transparency. And finally, it can learn from user feedback, which enables it to improve its performance over time and adapt to changing user needs. Its technical details includes using transformer-based architecture, which is well suited for natural language processing tasks. It is trained on large data set of questions and answers, which is sourced from various online platforms. And it uses the hyperparameters, which are tuned using the combination of grid search and random search to optimize its performance on training data. It is evaluated using the range of metrics, including accuracy, precision, recall, and F1 score to measure its performance on various tasks. Now, its results includes outperforming on other models on the question answering task, demonstrating its ability to reason and provide accurate answers. Also, it generates high quality text that is coherent, fluent, and relevant to the input prompts. Its limitations includes requiring significant computational resources, and here DeepSeek-R1 is only as good as the data it is trained on, and the poor data quality can negatively impact its performance. DeepSeek-R1 may overfit to the training data, which can result in poor performance on unseen data. Also, its decision-making process can be difficult to interpret, making it challenging to understand why it made a particular prediction. Its real-world applications includes virtual assistant. It can be used to answer questions in a wide range of domains from science and history to entertainment and culture. Also, it can be used to generate text such as articles, stories, and dialogues. It can be used in educational settings such as online courses and tutoring platforms to provide personalized learning experience for students. So this is the reference of the paper which we discussed in this. So in conclusion, DeepSeek-R1 is a revolutionizing AI model that has the potential to transform the way we interact with the technology and access information. Next comes Qwen 2.51m, which is a type of artificial intelligence model called a large language model. It is designed to process and understand human language like a super smart chatbot. 2.51m part refers to the model size and capabilities. It has 2.5 billion parameters, think of it like a brain cell, and can handle input sequences of up to 1 million tokens like words or characters. Its architecture includes Transformer 1, which is a type of neural network designed specifically for natural language processing tasks. Here the model consists of an encoder and decoder, where the encoder takes in input text and generates a continuous representation of input, and the decoder uses the representation to generate output text. Now this Qwen 2.5 works by where we give the model a piece of text, say a sentence or paragraph. Then the model breaks down the input text into the individual tokens, and encoder generates a continuous representation of input tokens. Decoder uses the encoded representation to generate output text, and the model produces a response like completion of input text or answers. Previous large language models had some limitations, like they could not handle long-range input sequences, they didn't perform well on tasks that required understanding complex languages. Also, they were computationally expensive. So this Qwen 2.5 to 1m overcomes these gaps by handling input sequences of up to 1 million tokens, making it suitable for tasks like document understanding or book summarization. It achieves state-of-art performance on various NLP tasks like language translation or question answering. It uses optimized inference engines and sparse attention to reduce the computational cost and improve speeds. The techniques used in Qwen 2.5 involves training the model on large data set with long sequences of text, which helps the model learn to understand and generate text in more coherent and context-dependent way. Progressive training is a technique where the model is trained on increasingly longer sequences of text, which helps the model learn to handle longer context and improve its performance on tasks that require understanding long-range dependencies. Data synthesis involves generating new training data by combining and modifying existing data, which helps to increase the diversity of training data. Sparse attention mechanism is a technique that allows a model to focus on specific parts of input sequences when generating text, which helps to reduce the computational cost and improve its performance on tasks that requires understanding long-range dependencies. Training free length extrapolation is a technique that allows the model to generate text of arbitrary length without requiring additional training. And this is achieved by using the combination of sparse attention and other techniques to extrapolate the model's understanding of longer context. Inference engine enhancement involves optimizing the model's inference engine to improve its performance and efficiency, which includes techniques such as caching, pruning, and quantization, which helps to reduce the computational cost of model and improve its efficiency and speed. Grouped query attention is a technique that allows a model to attend to multiple parts of input sequences simultaneously, and it helps to improve the model's performance on tasks that requires understanding multiple aspects of input sequence. Tensor parallelism is a technique that allows the model to be parallelized across multiple GPUs or CPUs, which helps to improve the model's performance and reduce its training time. Rope or the rotary position embedding is a technique that allows the model to encode positional information more efficiently and effectively, which helps to improve the model's performance on tasks that require understanding long-range dependencies. And finally, this length extrapolation is a technique that allows the model to generate text of arbitrary length by extrapolating its understanding of shorter context. Now, this Qwen 2.5 achieves impressive results on various benchmarks like MMLU Pro, Live Bench, Mathematics, and Science Task. Its limitations include requiring large amount of training data, which can be costly and time consuming. It still requires significant computational resources, especially for inference. It is challenging to understand how the model makes its prediction, which can limit its application. This is the reference of the paper which we discussed. So in conclusion, Qwen 2.5 represents a significant breakthrough in the field of natural language processing, offering unparalleled capabilities in text generation, understanding, and processing. Now this AI world is heating up with the three major players: Alibaba's Qwen 2.5, DeepSeek, and OpenAI's ChatGPT. Each is pushing the boundaries of performance, efficiency, and cost. So let's understand their differences in simple terms. First is the performance. So here this brain power, that is a performance, refers to how well an AI model can understand and respond to complex queries. So this Alibaba's latest model is a powerhouse, outperforming other advanced models like ChatGPT and DeepSeek in some benchmarks. DeepSeek R1 model is a dark horse, matching or exceeding the performance of ChatGPT and Google's Gemini in various tasks. OpenAI's ChatGPT is still the gold standard, leading the way in natural language processing and generating human-like responses. For example, you are a customer service chatbot and you need to understand and respond to complex customer queries. So Qwen 2.5 and DeepSeek R1 can handle these queries with ease, while ChatGPT is still the most widely recognized and used. Next comes efficiency, which refers to how well an AI model can perform with limited resources. So this DeepSeek's breakthrough lies in its source efficiency, achieving high performance. Alibaba's Qwen 2.5 offers significant improvements in handling complex tasks and long conversations while also focusing on scalability. While this OpenAI's ChatGPT is still a resource-intensive model requiring large-scale infrastructure. So imagine you are a startup with limited resources. You need an AI model that can perform well without breaking the bank. Here, this DeepSeek's efficient approach makes it an attractive option, while Qwen 2.5 and ChatGPT requires more resources. Next comes the cost, which refers to the development and training cost of AI model. So this DeepSeek's low-cost approach makes it more attractive option for startups and developers looking for cutting-edge technology without the hefty price tag. Alibaba's Qwen 2.5 benefits from competitive cost structure, making it a strong contender, while OpenAI's ChatGPT has a high development and training cost, making it less accessible from smaller business or developers. So imagine you are a developer with a limited budget. You need an AI model that can perform well without breaking the bank. DeepSeek low-cost approach makes it an attractive option. So in conclusion, the battle between the Qwen 2.5, DeepSeek and ChatGPT will shape the future. While ChatGPT remains the dominant force, DeepSeek's efficiency and cost effectiveness have forced competitors like Alibaba to rethink their strategies. So this is the conclusion. Next comes running DeepSeek model in Google Colab. So let's understand this DeepSeek better by running it in a Google Colab, and we will showcase the code so that we can make a chatbot using DeepSeek model. So let's get started with the code. So to get started with this code, first we need to clone the Genus repository from GitHub using this command git clone. And then this will download the necessary files and the code for this Genus model. Next, we need to install the required packages using this pip command. And these packages include the necessary libraries and dependencies for the Genus model to function properly. After this, with the environment set up, We can now load the genus model and processor using these codes. So here we are loading the genus model and the processor using this VL chat processor and auto model for the causal LM classes. We are also defining the model path and the loading the tokenizer, which is used to convert the text into format that the model can understand. To improve the performance, we can move the model to GPU using this command VLGPT. This will allow the model to take advantage of the GPU's parallel processing capabilities, resulting in faster processing time. After this, we will prepare the input data. So next we need to prepare the input data for the model. So in this case, we are asking the model to respond to the question about the image. We define the image path and question using this code. So here we are defining the conversation format where with the questions and the images, we are also loading the image using the load PIL. Then with the input data prepared, we can now generate a response using this code. So where we are preparing the input using the VL chat processor and generating the response using language model.generate, and then we are decoding and printing the response. So this will output the response to the question, which can be text description of the image. So as we have done the git clone, so we can see here we have got this repository of this one, we getting all the files, and here this we have given the path of the image. So we need to change this path of the images as per the required. So here we are using this image.png and we can take its path like this. So you can take the images as per your way. So here it's of the girl image. So that is why it's showing that the image shows a young girl sitting at a wooden table in which appears to be a cafe or similar things. So in conclusion, running this DeepSeek model in Google Colab is a straightforward process that can be accomplished with just few lines of code. Now the final question arises. The DeepSeek, a new artificial intelligence, has been making waves in the tech world. But is it safe to use? Because its privacy policy raises serious concerns. That is, it collects user data including text or audio input, uploaded files, feedback, chat history, and the technical information about your device like IP address, operating system, keystroke patterns, and your personal information, say name, date of birth, email address. And this data is stored on servers in China, which may not have the same data protection laws as other countries, and which raises the concerns about data protection and the potential misuse. For example, you are using DeepSeek to write a confidential email. If DeepSeek collects your keystroke patterns, it could potentially reconstruct the content of your email, compromising your privacy. Also, DeepSeek stores user data on servers in China, which may not have the same level of security as servers in other countries. This raises concerns about the security and potential misuse of user data. So suppose you are a journalist using DeepSeek to research a sensitive topic. If DeepSeek servers are located in China, the Chinese government could potentially access your research and identify you, putting you at risk. Now, a cause for concern is unusual activity. That is, some users have reported unusual activity on the platform, such as AI responding in a way that seems to be influenced by Chinese authorities. So imagine you are using DeepSeek to discuss a sensitive topic like human rights in China. If the AI responds in a way that seems to be promoting the Chinese government perspective, it could be a sign that platform is being influenced or controlled by external forces. Now, a cybersecurity risk is a threat to the user data. That is, DeepSeek has been hit by the large-scale cyber attack, which raises concerns about the platform security and the ability to protect user data. So suppose you are using DeepSeek to store sensitive information like passwords or financial data. If the platform is vulnerable to cyber attacks, your data could be stolen or compromised. Now, this DeepSeek privacy policy does not provide clear information about how user data is used, stored, or protected. So imagine you are using DeepSeek to write a confidential document. If the platform privacy does not clearly state how your data is protected, you may not know if your document is being shared or stored securely. Now, what do these experts say? So the cybersecurity experts and digital rights have expressed concerns about DeepSeek's safety and privacy policy. They recommend approaching the platform with caution and considering alternative, more trustworthy options like ChatGPT and OpenAI. So in conclusion, DeepSeek AI may seem like a convenient and affordable AI platform, but its safety and privacy concerns make it a risky choice. And that's the wrap. Our journey through the world of DeepSeek has revealed a revolutionary AI technology that is transforming the way we interact with artificial intelligence. From its ability to help us code smarter with DeepSeek-Coder to its advanced capabilities in DeepSeek-VL, DeepSeek-VL2 and DeepSeek-Prover v1.5, it's clear that DeepSeek is a game changer. With its potential to outperform other AI models like Qwen 1.5 to 1M and ChatGPT and its ease of use in platforms like Google Colab, DeepSeek is poised to disrupt the AI sector in unprecedented ways. Also, we have seen DeepSeek safety features and responsible development practices, ensuring that its power is harnessed for the greater good. As we look to the future, one thing is certain. DeepSeek is an AI technology that is here to stay, and its impact will be felt for years to come. Whether you are a developer, researcher, or simply an AI enthusiast, DeepSeek is definitely worth exploring. And we are excited to see the innovative applications and breakthroughs that will arise from this cutting-edge technology. Thank you.